and another shell out here, each with certain redshifts going on out. Of course, I've just made a simple circular diagram there. But if the Earth is far from the center, then if we look in all directions, we would not see these rings at all. It would just be all blended into random noise, random distances. And so the quantization is something that indicates that the Earth is near the center of a universe that is organized into shells. And so an Earth-centered universe nullifies a Big Bang assumption, which says there is no center and the Earth is not at a center. So another fault with the Big Bang. Okay, Russ Humphrey, yeah.
And would you explain that? I can't conceive of a universe that has no center.
Yeah, most of it can't.
What does that mean?
It just goes on forever. Yeah.
Well, but we know it's finite.
Yeah.
But still it has no center. Does that make sense?
No, it doesn't make sense to me. So, yeah.
May I suggest an answer?
Okay.
You take a balloon, blow it up. There's not a center, but there's an outer edge. The Big Bang says that it blew up and everything is around the edge, the outer edge. There's nothing in the middle. Humphreys is saying we're
that's a good analogy. If the two-dimensional universe has no
Yeah.
center, but ours is three-dimensional.
Yeah, but the Big Bang assumes that it is unbounded.
It would have to be infinite to not have a center.
Yeah.
If it's finite, it must have a center.
Yeah.
So they go hand in hand.
Yeah.
They're mutually exclusive. No
Yeah.
center and finite are mutually exclusive.
Way in the back.
The balloon thing's a simplistic, if fallacious explanation. There's a center. Whether you can find it or not is immaterial. There is a center.
Yeah.
If the outside keeps expanding, there's still a center. It might be one molecule on Saturn's inner ring or something. There is a center.
Okay, Humphreys, white hole cosmology. It's in his book Starlight in Time, which came out a decade or so ago. Russ Humphreys, who's been a speaker here, he uses Einstein's general relativity theory to model a possible creation of the universe, and gets into all kinds of fancy mathematics, but he's using the stuff that the scientists have already sort of established is a fairly good theory. Okay, he starts with the idea that the Earth is expanding from a point, and it's God who enables this. It's not something, the first law of thermodynamics comes later, after everything is created. And so this is opposite of the black hole process that God behind it. He lets the matter escape out through this thing called an event horizon. Now, normally that is the point of no return in a black hole entry. Things coming into that cannot get out. But anyway, this event horizon, as the matter is expanding out through it, the event horizon itself shrinks down towards the center. And so matter getting outside of this event horizon ages in a normal manner. Matter inside or on the event horizon has a near zero aging according to relativity theory. The clocks are stopped with respect to the rest of the universe. And that means that if the Earth is near the center, and I've lost my cursor there. If the Earth is near the center of an expanding universe and was inside the event horizon until recently, then the rest of the universe can have aged billions of years, while the Earth aged only thousands of years. And that's the gist of his Starlight in Time theory. And since 1994, when he proposed this, it's held up fairly well against critics, and he's developed it slightly with more refinement, more observations, or theoretically. There's still room for criticisms, but it seems to be a fairly robust theory.
Real quick before you leave this
Yeah.
idea. If that's true, the problem I had when I first read this was if there's an event horizon that's still outside of us, wouldn't you expect a discontinuity in redshift rates right at that point?
Yeah.
Do you expect to see an abrupt change in redshift
Yeah.
at that point?
Well, the idea is that the event horizon has already gone past us,
Okay, so if we're in the center,
near the center.
near the center, how can
Yeah.
we go past this? I mean, that's where I had trouble.
Yeah.
You expect to see a discontinuity in redshift at the point of the event horizon. And if the event horizon, if we're the center, the event horizon cannot be past us. In other words, it has to be,
Yeah.
it has to be somewhere between us
Yeah.
and something out there.
Yeah. The idea here is that we're near the center, not at it.
Okay.
And that once all the matter's out, then it's no longer a black hole, and the event horizon vanishes, so we can't even see it.
Okay, it must be pretty small.
Yeah.
Because in order for the rest of his theories to work, we have to be pretty darn in the center.
Yeah.
And I had trouble with that. I didn't know if you can answer that.
Of course, going to Russ Humphreys, the ultimate guy there. But that's my understanding is that the Earth is not at exactly the center, and that the event horizon has passed us. And so now aging processes are all going on normally, but we're like thousands of millions of years behind the rest of the universe.
Still expect a redshift jump between us and the center. So somewhere,
Yeah.
you should see a discontinuity in redshift if that's true. And I didn't know the answer to that
Yeah,
objective. I didn't
but it could be that there's nothing at the center anymore,
that could-
and so there's nothing to detect.
Okay, I mean, that'd be the only
Yeah.
answer.
In my chapter in this book, I discuss the astronomy and the problem with the universe appearing to be millions and billions of years